Now in the last part of the syllabus, we're going to look at a particular branch of chemistry called organic chemistry. Alright, some of you all may have heard of the term before when we talk about organic solvents. So what exactly is organic chemistry? Organic chemistry is the study of carbon containing compounds. Okay, so most of the time these compounds contains not only carbon, but it also contains hydrogen, oxygen, and sometimes chlorine or even nitrogen. Okay, so before we even go into an in-depth study of this class of compounds, alright, those of you who are sharper may be able to deduce some of the properties of organic compounds already. Okay, how so? If again organic compounds contains carbon, most of them contains hydrogen and oxygen, and sometimes chlorine and nitrogen. Now if you think about it, all these atoms are non-metals. Alright, so when they combine together, what kind of compounds would they form? They will form covalent compounds. Okay, and covalent compounds with what kind of structures? With simple molecular structures. Alright, so before we even look into the few or the types of compounds that can be formed, we can already generalize that organic compounds, they have simple molecular structures, therefore they will have properties associated with compounds with simple molecular structures like low melting point, boiling points, okay, cannot conduct electricity in all state, and also that they are insoluble in water. Okay, so in order to, before we can go into the study of organic chemistry, we need to learn three new terms. Okay, they are homologous series, functional group, and nomenclature. Okay, so we will start by introducing these three terms before we go into the study of organic compounds. Now, what is a homologous series? Homologous series is actually a family of compounds. Okay, now let's focus on the word family. Alright, when you look at the members of a family, sometimes even without them introducing themselves, you can already tell that they are members of a family, right? How so? Alright, most of the time, if you look at the members of the in the same family, they actually have the same features, correct? They have a sharp nose, or they have a round nose, they have very small eyes. Alright, so members of the family, they actually share the same features. Okay, now even if they don't look alike, sometimes you can even tell that they are members of the same family. Why? Because they behave in a similar manner, or they talk in a similar manner. Okay, so these are the two things that I want you to keep in mind, that members of the family, they have the same features, they behave in a similar manner, and of course the one thing that is common for all of them, they share the same surname. Okay, so now we are going to plot these three or rather two of these three characteristics into chemistry. Alright, you're going to see an unfamiliar term, but don't worry, we're going to define that next. So as mentioned, homologous series is a family of compounds which has the same functional group. I know we have not learned this term, functional group, but for now you can treat it like the features. They share the same features, okay, and similar chemical properties. What do I mean by chemical properties? Means that they undergo the same type of reaction. Okay, so homologous series simply means a family of compounds that shares the same features of functional group and they behave similarly, they undergo the same type of reactions. Now in the syllabus, we're going to just look at 4 different families. Okay, the families of alkanes, the family of alkenes, family of alcohols, and the family of carboxylic acids. Alright, so these are the 4 homologous series that we're going to look at. Now, as mentioned, we're going to define now what is a functional group. Previously, we have seen it in the definition of homologous series. I told you all that is the features. Alright, so when we look at a particular organic compound, alright, there will be either an atom or a group of atoms that tells you which family it belongs to. Alright, and it's also this group of atoms that gives the family its unique characteristics. Alright, so as mentioned, we are going to look at 4 different families. For alkanes, there are no functional group, so there's no distinctive feature. There's only carbon and hydrogen. Okay, for alkenes, the functional group is a carbon-carbon double bond. Alright, a carbon-carbon double bond that tells you, when you see a carbon-carbon double bond, it tells you that the compound belongs to the homologous series of alkenes. Okay. Then for alcohols, it has this particular functional group, your OH functional group. Okay, so whenever you see a compound with OH group, it tells you that the compound belongs to the alcohol functional group. And lastly, for carboxylic acid, you will see this particular group of atoms, your COOH group. Alright, so again, one last time, if you see a compound with COOH, it means that it belongs to the carboxylic acids functional group. Okay, so to quickly summarize again, to recap, alkenes contains the carbon-carbon double bond functional group. There's a little question that I always like to ask at this point in time, which is that you know, the carbon-carbon double bond in the field of chemistry, we often don't regard it as a very manly bond. Alright, do you all know why? Right, because we always call it a CC double bond. Okay, so alkenes contain a CC double bond. Now for alcohols, it contains the OH group. There's a name for this group, we call it a hydroxyl group. Okay, hydroxyl group. Carboxylic acids contain COOH group. There's also a name for it, we call it a carboxyl group. So the last term that we need to define or find out more is called nomenclature. Nomenclature is simply a high-class name for a name. Alright, so we need to learn how to name an organic compound. Alright, the name of an organic compound is split into 2 parts. Okay, the front part is called the prefix. Okay, and the back part is called the suffix. What can we tell from the prefix? We can tell the number of carbon atoms. Alright, so the front part of the name will tell us the number of carbon atoms. The back part of the name will tell us the family that the compound belongs to. Alright, so from the after knowing the family that the compound belongs to, we can also determine the functional group or the feature that's present in the compound. Okay, so as mentioned, prefix or the front part of the name tells you number of carbon atoms. So in our syllabus, we're going to learn by right only up to 4, but I'm going to tell you how to name from 1 to 6 in this lesson. Now, if an organic compound contains only 1 carbon atom, the front part of the name would be meth. Okay, and then if it contains 2 carbon atoms, the front part will be eth, and prop, bute, pent, and hex. Okay, so based on the front part of the name, whether it's meth, prop, pent, or hex, we can tell the number of carbon atoms in that organic compound. Now for the suffix, which is the next part of the name, the back part of the name, it tells you the homologous series. Okay, so if the compound is an alkane, the name, next part, the later part of the name will be ane, ane. Okay, if the compound is an alkene, it will end with ene. If the compound is an alcohol, it will end with anol. If the compound is a carboxylic acid, alright, it will end with anoic acid. Okay, so take some time to try your best to remember the names for the prefixes and the suffixes now. In a while, we're going to practice with some examples. Now, there are three organic compounds given on this page. Alright, you can see that it contains carbon, it contains hydrogen, some of them contains or one of them contains oxygen. Okay, so we're going to try to name these three compounds. Alright, first thing, let's try to identify what homologous series or what family does it belong to. Okay, A, if you look at A doesn't seem to contain any special feature in there. Alright, so A is actually an alkane. Okay, how about B? B, I hope you can see that it has this special feature, which is your C double bond O OH. This tells you that it belongs to the carboxylic acid family or homologous series. Okay, and for C, I hope you can see the not very manly double bond. Okay, your carbon-carbon double bond, which tells you that it is an alkene. Alright, or it belongs to the alkene functional group. Okay, now that we know the family or the homologous series, we can tell the later part of the name. Okay, and to get the front part of the name, we need to look at the number of carbon atoms. So for compound A, we have 3 carbon atoms, and for 3 carbon atoms, the front part of the name is prop. Okay, since it's an alkane, it will end with ane. So compound A is known or has the name propane. Okay, compound B has 1 and 2 carbon atoms. Right, so for a compound with 2 carbon atoms, the name will start with S. And since it's a carboxylic acid, it will end with anoic acid. So this is your ethanoic acid, which we have already learned in acids and bases. Alright, so now you would be able to better appreciate why is it called ethanoic acid. Alright, which is also your vinegar. Okay, and lastly, we look at compound C. Compound C contains 1, 2, and 3 carbon atoms. So again, it will start with prop, and then since it is an alkene, the later part of the name will be ene. So the name for compound C will be propene.